Good evening, everyone. My name is Markus, and today I'd like to talk about a few things in Postgres you might not have known about. So I'll mostly be talking about Postgres 9.4. Not all of the features I mentioned today are available in the low versions, but most of them are. So the first thing I want to talk about is how it's pronounced. You've already heard that it's called Postgres or PostgreSQL, not Postgres something. But as Tom Lane, one of the core committers, admits, the decision to call it Postgres was not the best one. In fact, you read that right, it was the single worst mistake this project ever made. But people have come up with better alternatives. So the first thing I'd like to talk about, anyone who has ever used Postgres in the past has probably had to deal with these things called SHL max and SHL min, because otherwise Postgres wouldn't run. In 9.3, those are gone, and you can now actually just use Postgres without modifying your kernel parameters, which is a very important feature for me because I always hated that. And okay, so the first real feature I want to talk about is PSQL. PSQL is the command line client for Postgres. And it has a lot of neat features, I hope you can read that, to actually work with your Postgres database and the tables within it. The first one is \e. \e basically does just one thing. It opens your favorite text editor, and then you can edit a query or write a new one inside the text editor, save it, and then just close the window. And then you have this query just wrote inside your prompt, and you can execute it. You can also use it to edit an old query and then just re-execute that. You can also use it to list all the databases in your cluster, or list all the tables and functions and what have you in your database. And like most commands in PSQL, it has a more powerful version if you just append a plus. Another neat feature is if you select from a table which has many columns, then the problem is that there's so many columns they won't fit on your screen. But if you do \x auto, then PostgreSQL will see, oh, you have too many columns, they won't fit on the screen, I'll switch to different formats, you can still read your output in an easy way. And you can also use these settings, if you like, to make the output PSQL produces for you much nicer. And you can also use this to see how fast your queries that you're running in PSQL, how long they take. So, and if you put all of this into your PSQL RC, then you will get this every time you start up your PSQL. And this makes PSQL for me pretty much the only interface I use to look at the data in my databases or interact with it, apart from writing code, of course. But I don't actually use many GUI tools because PSQL is much more efficient and much quicker to interact with my databases than pretty much all GUI tools in my experience. So the next thing I want to talk about is data types. So this is a quote from James Edward Gray II. And a few months ago, he spent some time reading the data types of documentation of Postgres. And as he says, it's one of the key features of Postgres is that it has many different data types available. This is just a small sample of those data types, the non-standard data types, of course. For example, you have network address types. So if you're dealing with network addresses, there's actually a data type in Postgres that will validate your network addresses for you, so you don't have to do this yourself. You can also use UUIDs, which are great for primary keys, but you can also do things like custom enumerated types. So if you have a data type where Postgres doesn't offer you one that actually fits the data you have, you can do your own one. And I'd like to talk about that for a second. So, for some reason we've decided we want to become marine biologists and we need to track squid. And we want to track all this data about squids we're going to collect inside our Postgres database, of course. So, we want to create a type called squid, where we can track the different features of squids, the length, the number of tentacles, and its weight. And then we create a table for the Atlantic squids and one for the Pacific squids. And I'd like to also show you this. This is a pretty neat syntax to create a table with the same columns as the other one without having to type all this stuff again. And then it's very simple for us to use our new composite data type. We just have to have all the values in the same order as we defined them, and then just cast into Squid, and it works. And you have your custom data type inside a column as a column type in your database. And obviously you can easily query your data. So the next big thing about Postgres are extensions. As with data types, there are many extensions available. I'm not going to talk about all of them because there's many of them. I'm going to talk about HSTORE in detail in a minute, but I would like to mention the other ones. CI text is very interesting because CI text is basically a text data type which is case insensitive. So if you have to compare a lot of text case insensitively, you can just use this data type and don't have to worry about converting your text to upper or lower case beforehand, because Postgres will do it for you. So, HSTORE. Basically, HSTORE is a way to get NoSQL into your SQL. It's a key value store as a column type, as you can see here. We just create a new column with the data type HSTORE. You should usually default this to an empty string and make it not null, because otherwise you have to be with empty HSTOREs and null HSTOREs, which is not fun. And then you can easily use this new column. We just insert 2 columns, the email, which is just a normal text, and then this here is our key value store. It's just the keys are on the left, and this means next is the value. And as you can see, it's pretty straightforward and easy. You can also query this. So for example, if we want to have all users whose GitHub username is Cypher, then we can easily query inside this HSTORE column. You can also, Postgres also offers a lot of other, here's just an example of functions to interact with your HSTORE columns. In this case, we want to get all the keys from our HSTORE column, but you can also get all the values or do other operations on them. The docs offer all the information on that. Another neat feature are hyperdimensional cubes. I'm not going to talk too much about them, but basically, say you have a movie database and you want to rate your movies on different axes, because no movie is just a comedy or just a drama. And we say, okay, each genre is just an axis, and we probably have many of these axes. And if you have just 3 axes, you can easily imagine that, because it's just basically like space, and you have one axis comedy, one is drama, and one is thriller, and each movie is somewhere inside this cube then. And then, for example, if you want to find movies which are similar to this one, you just have to have search the space around it. And hyperdimensional cubes are the same things, just with more dimensions. So you can do this, which has a lot of dimensions, and then you can ask Postgres, okay, I want to get all the movies which are very similar to this one. And Postgres can do this very efficiently. So in this case, you can see this movie here is Star Wars, and we're looking for movies similar to Star Wars, and you can see Star Wars Episode 5, The Empire Strikes Back, is very similar to Star Wars, obviously. Another great new feature in Postgres are JSON data type and PLV8. So JSON is just basically a new column type you have. It's just text, but with JSON validation. So you can insert JSON into your tables, and Postgres will make sure that that what you're inserting is actually valid JSON, so you don't have to do the validation yourself. But then you can also do stuff with this JSON data inside a database. For example, you can convert your rows to JSON for further processing. You can also query JSON columns, as you can see here. If we want to get the second index of this array in JSON, we just say, okay, we want the key A and then this second index. So it's 0 based, of course, so 0, 1, 2, and it's of course 3. You can also enumerate these key values, as you can see here. Or you can, for example, do extract values deeply nested within the JSON. And as I mentioned before, Postgres supports PLV8. What this basically means, the V8 JavaScript engine, which you may know from Node, is integrated into Postgres, and you can then use V8 and JavaScript to write functions inside your Postgres database, for example, to use as triggers, if you want to. So the next thing is arrays. You probably already know arrays from programming, but they're also in your database. using them is pretty straightforward. You just declare your data type and append the square brackets to make it an array. And in this example, we have a table called posts. And in this case, we're just storing the tags for each post as an array on each row. And this, for example, this query, this looks for all posts that are tagged with Ruby or Rails. And this query finds all the posts that are tagged with both Ruby and Rails. So as you can see, this is Ruby or Rails, and this is Ruby and Rails. The next thing, you see there's a lot of them, are ranges. Ranges are basically what you know. You have a date range, for example, and you can check if a given date is inside a date range using Postgres. And we can use this feature, for example, to manage reservations at a hotel. So we can say, okay, we have rooms, and the rooms are just room numbers, and they are reserved for a time range. So with this, always this start timestamp and an end timestamp. And then it's, for example, easy for us to see if a room is reserved or look for other reservations we have for a certain date. And we can actually make sure using a GIST index, this is here, to make sure that no room is double booked, which is of course something we usually want in a hotel, because that would be bad if you double book rooms. And then if you try to insert a reservation for a room that has already been booked, you will get an error, and Postgres tells you that you can actually do that because the room has already been booked for this time. So the next thing is indices. Markus will tell you much more about them later on, but I'm just going to mention a few things about them. There's many different types available. B-tree is the one you're probably going to use the most, and it's also the default, and it supports comparisons and is basically the safe choice. But there's also others available. Chins are for columns that contains more than one values, like arrays or HSTORE columns. And you also have GIST indexes, which are great for things like full text search, which I'll also talk about later. And there's also other things like KNN, which is KNN is K nearest neighbor, which is great for location searches if you want to find quickly find things that are near something. And I actually have no idea what SPGIS does. I've heard it's very powerful and it makes some people very excited, but no one has actually been able to tell me what it's good for. Another neat feature of indices in Postgres is this, because usually if you create an index in Postgres, it will actually lock the table for the duration of the creation of the index. This is obviously something you usually don't want, because you want the user to be able to use your database. And creating an index concurrently, this means it will take longer to create the index, but it also won't lock the table, so people can still use it and query it. And you can also, another feature that you might not have been aware of is that you can actually have partial index on a table. So for example, if you have a users table, then and we have maybe a feature which allows us to delete users, we're usually only interested in users which are active. So we can create just an index which is only on active users. Or we want, for example, only posts which are not deleted. And then Postgres will create this partial index for us. Another great thing is pgstat statements. This is basically a built-in extension which allows you to collect statistics about your statements. This means you can actually see what queries you've run, how often have they been called, and how much total time they've taken. This is very good for knowing which queries are run very often and which one takes a lot of time, and basically using this feature you can look at the queries which you will need to optimize first. Another thing that Postgres offers for you is full text search. For example, this you might have already known this. You can basically do a glob search. You can look for all the movies which start with Stardust. But you can also use, for example, regular expressions to query. It's very easy. You just need to use the NET operator. So in this case, we look for all movies which do not start with the. But you can also use things like Lebenstein distance. You might not know what Lebenstein distance is. It's basically a way to quantify how far apart two words are. So if only one letter is different, then they're very near, of course, and then if all the letters are different, then they're very far apart, of course. So this, for example, allows us to look for all the movies whose title is very near to this string, and obviously that's going to be this movie. But you can also use things like trigrams. Trigrams is basically a way to encode words in a way, as you can see here, in a way which makes it easy for us to index them. And if we actually use create a GIS index on this table, then using this trigram, we can, for example, find movies, in this case Avatar, with a misspelled word. So this allows us to have a very fuzzy search for our users. But there's also an actual full text search available. For example, we can look for all the movies who have night and day in their title. Sorry, night or day. Night and day, was right. And then, of course, you can find these three movies. And this is actually really fully indices your text and actually looks for these two words. And you can actually use this with different languages as well. So different languages have different ways how they, for example, pluralize words. And Postgres has rules for many languages. I use English in this case, but many languages are available for this feature, and you can use this to search in languages, in text that is written in languages other than English, in a way that is actually makes sense for this language. Yeah. And you can also use another feature is that, like, if you have, for example, a very misspelled name. So in this case, we're looking for an actor called Bruce Willis. And our usual methods, of course, fail us because there is no actor with this exact name. But we can use metaphones. Sorry, it's very small, you probably can read this, but metaphones is basically another way to encode words. We can use this to find all the movies where this actor, Bruce Willis, has played. And of course, we get things back like The Fifth Element and 12 Monkeys. Okay, so the next feature I want to talk about is common table expressions. Common table expressions is basically a way to make very complicated queries easier to write and read. So for example, let's say we have this table, it's called departments, and we use it to enumerate our departments and have their relationships. So we have one department at the top, and then there's many departments below that, and we want to encode basically which department belongs to which other department. And we can then query this department table. Using a common table expression, we can actually do a recursive query on this table. So using this common table expression, it starts with a with. Then you can use recursive if it's going to be a recursive query. This is the common table expression part, where you have the actual subquery. And then down here you have your normal query. And in this case, we just select all the things we get from this subquery. You can also use this for other things, like, for example, you can delete from one table and then return the stuff you just deleted and insert it in the same statement into another table. Which is great because you can use this, for example, to archive data from a busy table without running the risk that you delete it, but then something happens and you haven't written it to the new table yet. So I've already mentioned that you can do regular expressions. Just a few more things. It's basically all the things you know from regular expressions. New in Postgres 9.3 is also updatable views. I don't know how many of you have used views before, but basically before 9.3, views are basically just, you said, okay, you have a query, and this is your new view, and every time you query the view, the query is run by Postgres in the background. But Postgres 9.3 and 9.4 have a feature called updatable views. So this basically means we create, so this means two things for us. First of all, we can create views. For example, in this case, we have a new view Postgres version 9. So this is all the Postgres versions that start with 9. And we can then actually use this view to insert new data into the underlying table. So the underlying table is Postgres versions. And we can then just insert data into this view, and Postgres will figure out, okay, what we actually want to do is insert data into the underlying table, and will do that for us. But what's also very neat about 9.3 is that we now have materialized views. Because as I mentioned before, views are actually just a query that is rerun every time you query the view. With materialized views, you can actually create a physical, basically a temporary table with the data from your view, which you can then query, and you can also index it. So this means that your views are now much more performant than they were before. And the problem right now in 9.3 is that you can refresh these with this command, refresh materialized view. But the problem is that in 9.3 this actually locks the view, so you can't query it while it's being updated. And in 9.4 they will introduce a concurrent version of this, so you can actually, just like with the indexes, update your view while you can still query the view itself. So another very nice feature is streaming replication. This is basically straightforward. You have a master server and you have a replica server, and then you can just stream everything that is written to the master server in real time to your replica. But what Postgres right now can also do is do remastering. So basically, you have, as I just said, you have maybe two database servers. One is the master, one is the replica. And for some reason, you need to take the master down, for example, for hardware upgrade. What you can now do with Postgres in 9.3 and 9.4 is promote the replica to the master very quickly. And then just reconfigure your software to use the new master, take the old master down, do whatever you need to do, bring it back up again, and then just say, okay, you're the new replica of the new master. As I mentioned, you can do very fast failover now, because all you need to do is touch a trigger file, and Postgres will promote your previous replica to your new master. Something else that Postgres offers is actually a very simple queue. Postgres calls this listen and notify. For example, we have two different shells here, and we say, okay, the first one we want to listen on the work available queue. And on the second one, we can notify this queue, work available, that there's a new job with the ID available. And then, as you can see, in the first shell, we actually receive an asynchronous notification. You can also do this with functions if you need to, because this feature won't work with all client libraries. But if you can use this, you can also use this function to get notified or notify other listeners of stuff you can do in your queues. And if you're using Ruby, there's actually a gem available for this, written by Heroku. So if all you need is a simple queue, then Postgres offers that for you as well. The next thing is foreign data wrappers. Basically, as the name promises, they wrap foreign data. For example, this is no joke, you can actually do this as a foreign data wrapper available for Twitter. So you can actually query Twitter using SQL, and in this case, for example, I want to have all the tweets that are hashtagged with VNRB. These foreign data wrappers are a bit more useful than the Twitter one. You can actually foreign data wrap other Postgres databases, so you can query the tables inside this. You can also connect to, for example, a CSV file and query this and import data from the CSV file. Or with JSON, S3, Oracle databases, MySQL. Basically, there's many different adapters available which you can use to read from other databases or files and stuff. And some actually allow you to actually write back to the data store. PostGIS is basically geographic goodness for your database. It's basically a very big project, and it deserves a talk of its own. So I'm not going to go much into it, but basically it allows you to run queries like, for example, how near are these 2 points, or give me all the points which are near this location. You can actually run these as SQL queries inside the database, and Postgres offers you all the functions and data types you need to do that. PostgRES-HLL. HLL is hyperloglog. Hyperloglog is basically a data type which allows you to estimate the count of very large values. By very large, I mean tens of billions of distinct values. And it does this very efficiently using very little space, and it has only a small percent error. So this is basically for when you don't actually care about the exact count of something. You just need to have a very close count of what it actually is, and you need to do this very quickly and efficiently. And PostgRES-HLL is for that. So this is not actually a Postgres feature itself, but a web page. But this is basically a web application where you can pass the output from an explain statement. Then we'll use this and actually show you which part of your query is actually slow. So you can easily see this part of the query is slow. And this makes parsing explain output much easier. So 9.4 hasn't actually been released yet, so there's actually a small preview of what's to come. As I mentioned, we can now refresh the tier as we use concurrently. The foreign data wrappers will be writable. We have more application improvements. There's also going to be PG pre-warm, which solves the problem that if you restart your database and your caches are cold, then it can take a while for them to get warmed up, and PG pre-warm will do this for you. And you can also now alter system configuration of your Postgres database while it's running. So to recap very quickly, it's pronounced PostgreSQL, or if you want to be even better, but it's unofficial, it's PostgreSQL. There are very many handy data types available. There are also lots of handy extensions. There's HSTORE, which is NoSQL in your SQL. There's also JSON and PLV8, which is WebSQL in your SQL. Arrays are obviously useful. They're also available in the database. Use them. You can use common table expressions to make complicated queries easier. You have ranges, you have full text search built in, and you have materialized views. So what I actually want to do with this talk is not just tell you about all the great features Postgres had, but actually drive home the point that Postgres isn't just a SQL database. It's actually a very powerful data platform. So I hope I could show you what Postgres can actually do. That's not just a dumb SQL store for you, that it can do many great things with it that can actually make your life as a developer much easier. And yeah, thank you. Questions?
Okay, this time we did an experiment and we also have questions on Slido. So if there are no live questions yet, I will ask something from Slido. And one is, what are the drawbacks of using PostgreSQL, if you know of any?
So for me personally, biggest drawback of Postgres, which when I was a beginner was most obvious, is that Postgres is a bit complicated to actually set up and use. So if you've ever looked at the configuration file, there's a lot of different stuff available in there. And it actually takes a good while to actually get to know Postgres and actually be efficient in using Postgres. And as you've just seen, there are a lot of other features available besides the normal SQL standard features ones. And to actually really efficiently use Postgres, you basically need to know about all of them beforehand. So that's basically the biggest problem with using Postgres, is getting to know all the features and the very high barrier of entry. So it's not just like, okay, install Postgres, start it, and then everything just works quickly.
Still no other live question. I will continue from Slido. What is your most favorite feature you use the most? And on the other way around, what feature you are missing the most?
So basically the feature I use the most actively is actually HSTORE, because it has allowed me to make the tables I use to be much more flexible. So for example, the company I work at, we do food delivery, and we have, for example, a restaurants table, and we have always a lot of different attributes we have to store for the restaurants, and previously we would always add a new column for each new attribute we would get. But now we just basically have an HSTORE column which stores all the attributes of restaurants which aren't used very often, and that's actually made us much more agile with in terms of features we can actually develop for these restaurants, because now we can say, oh yeah, just no problem. We don't have to migrate our database every time we want to add a new feature for restaurants. And as for the worst feature, basically that foreign keys are very expensive. If you have a table which has a lot of foreign keys, Postgres will check the integrity of that, but it actually takes noticeably longer to insert data in such a table. And this is actually something that could be done much better in Postgres because other databases do it better as well.
Yes.
And the last question, what about what about performance, especially when we are talking about fuzzy word searching and so on? How it is about performance and benchmarks in comparison with another databases, for example, MySQL and so on?
So I actually don't know how it compares to other databases because I haven't really used the other ones. But Postgres actually offers specialized index types. GIST and GIN are two you're going to use very often in these cases. So, because basically whenever you do a query in a database, the performance comes down to the indices you have, and Postgres allows you to create the right index with the right types on the right set of data you want to query. And so queries, even on, for example, a table which contains a lot of text, can be made very efficient using the right index. But that's again, with the first question, you have to know that this index exists and how to use it correctly to make it efficient beforehand.
And question about algorithm. Which algorithm are you using for this? Which special algorithm are you using for this? Because I know, I think, two algorithms for searching words in text, and they are performing. It depends on the case you are using it. So I would like to know which algorithm are you using, are you employing in this job, especially fuzzy words.
I honestly don't know. I would have to look it up in the documentation on the exact algorithms they use. But it's basically it's provided by Postgres. They have ways to index it to make it very efficient, and it works very well for my use cases. But my use case, for example, is my text is all in German, so I only have to use this one language. So that makes it a bit easier for me and probably for Postgres as well. But I'm sorry, I can't tell you exactly what algorithm you use, but they are documented in the documentation, so you would have to just look them up.
Yes.
Provided your wide knowledge of Postgres, did you try to use independent indexing solutions, or you only depend on the Postgres indexing?
In my job, I've only used the Postgres indexing solutions. I haven't used any external ones or third-party ones. Any other questions? Okay, thank you very much.